Hello, it's Martin from Wisely Automotive, and in this video we will be looking at our Porsche Taycan Cross Turismo. Engineering and technology-wise, it's a very interesting vehicle because it was one of the first truly enthusiast-level electric cars on the market, which could not only achieve excellent straight-line performance, but also deliver in areas such as handling and more of the subjective driving characteristics. To achieve that, Porsche used a lot of new things in the market for EVs, and if you look at them from an old-school point of view, it's very easy to misunderstand them, and this is in fact what we oftentimes see online. So we can dive right in, starting with the two-speed gearbox. I've taken some notes because there are quite a few numbers to go through, but in general the Taycans can come with multiple drivetrains. The base version of the sedan is exclusively rear-wheel drive powered by a single motor on the rear axle, and if you step up to any of the other versions, so the 4, 4S Turbo or Turbo S, you also get a front motor for all-wheel drive. Regardless of the version though and the power tune, the rear motor powers the rear wheels through a two-speed gearbox. This is quite a novel solution because usually with EVs we have a single-speed reduction gearbox without any clutches or variable gear ratios. And with the Taycan being a properly German car which can handle high-speed runs on the Autobahn, it created this illusion that you need a gearbox in an EV to achieve and sustain high-speed driving. That's not quite the case though, and to fully understand it we need to look at the numbers now. Again, the rear gearbox is identical across the entire Taycan range. The first gear has a gear ratio of 15.5 to 1, and the second gear is about 8 to 1. And just for completeness, the single-speed reduction gear set on the front motor also has a ratio of about 8 to 1. For context, something like a Tesla Model 3 long range, which also has a more powerful motor on the rear axle for a rear-wheel drive bias, obviously only features single-speed reduction gear sets with the same 9 to 1 ratio on both front and rear axle. That means that the gear ratio on the Taycan's second gear is barely longer than on the Model 3. And it's the first gear which differs drastically, and that's how you have to think about it as well. With this being an EV, there is no need for a traditional torque converter or a clutch which allows slip because there is no engine to stall. The first gear only engages when you need maximum launch power, so in launch control mode or when you kick down the accelerator at speeds roughly below 50 miles per hour. There's no indication in the car whatsoever about which gear you are in, but if you kick down the accelerator at these low speeds, you can definitely feel the gear change because the car starts accelerating in second gear, pauses for a second, and then really launches into first. Some may say it's more engaging and interesting to drive. In my opinion, it really ruins one of the nicest things about EVs, which is consistent acceleration and very little disconnect between the driver and the machine. Mind you, there is no way to select which gear you are in yourself, and with the Taycan not having paddle shifters for even regen, it's very unlikely it could be added as a software update down the road. To get all the negative points out of the way, also it obviously adds a bit of volume to the entire drivetrain assembly, so the rear boot, while perfectly usable, especially in this Cross Turismo variant, it definitely does not have as much underfloor storage as some of its competitors. But let's get back to the original point, which is enabling higher top speeds for EVs. Is it any good for that? If we compare the specs of the best Porsche Taycan, which is the Turbo S, and the best Tesla currently actually available on the market, which is the Model S Plaid, we can very easily spot that the Taycan, despite having the gearbox, and the Model S only featuring single-speed reduction boxes for each of its 3 motors, the Taycan is slower to accelerate from a standstill. Now, we need to admit Tesla likes to be very optimistic with their numbers and Porsche quite pessimistic, but even real-world tests have shown that the Model S is faster. The Tesla can also sustain that power into higher speeds and can reach a higher ceiling at 200 miles per hour versus 162 for the Porsche. All of that from a 400-volt system, not 800 volt. One thing the Taycan has in common with the Plaid is that they both feature an all-permanent magnet motor setup, with Porsche claiming the Synchronous PM motors are the best solution for efficiency. Let's be honest with ourselves, we know the Taycan is not the most efficient electric car out there, so what happened? While in theory, on a lab bench under identical load conditions, a permanent magnet motor may be more efficient than an induction motor, the reality is, as with anything, they each come with their own set of compromises which you need to know how to work around. PM while more efficient and more efficient to package because it can provide more power from a smaller motor, they can be susceptible to torque ripple, especially at very high rates of acceleration. So I'm talking about scenarios like launching from a standstill or going at a constant speed and suddenly flooring the accelerator pedal and asking for maximum output. That has to be worked out because torque ripple is not healthy for the motor itself, and it would feel like the car is literally falling apart, which is not desirable in a premium EV. One way of going around it is artificially reducing the jerk, which is the definition of rate of acceleration, for a slightly smoother torque application, which combined with clever motor control can minimize the rippling effect. Another important trait of permanent magnet motors is that they cannot freewheel, because as the rotor which houses the magnets spins within the stator, it also induces an electric current. And without being able to disable the magnets, you're pretty much always bound to this happening to a certain extent. The positive side of that is that you can apply regenerative braking all the way down to zero, which again increases efficiency, and if you are an EV driver used to regen braking, it's something which we all appreciate. It does become a bit troublesome with the all-wheel drive system though, because if you have two permanent magnet motors, there's less flexibility about prioritizing one over the other, because essentially both of them have to be energized at all time. Porsche's solution is to use the clutch in the rear gearbox to completely disengage it and the motor from the drivetrain. That means that in the range mode, the all-wheel drive Taycan is pretty much a front-wheel drive car and only engages the rear motor should it need more traction or you're asking it for more power than the front can deliver on its own. The Cross Turismo can be only had with all-wheel drive, but if you're considering the base-level Taycan sedan, which is rear-wheel drive only, and you are thinking the simpler and lighter design will be the best for achieving the maximum range, which is often the case with many EVs, I would definitely reconsider that. The weight penalty for the front motor is only about 90 kilograms, combined with the fact that the rear motor has to deliver the power through the two-speed gearbox, which realistically will add quite a bit of friction, or in other words, losses into the system. You will most likely get the same, if not better range from an all-wheel drive version. We need to pause here for a second, because as I was editing the video, some news have come out that Porsche has introduced a 2023 model year Taycans. There are quite a few changes in the log, but the most important one for the purposes of this video is that the drivetrain software has been tweaked and the all-wheel drive handles a bit differently now. According to the press release, the front motor will be now de-energized more often. That would suggest that, unlike previously, the rear motor, even though it has a gearbox, will be prioritized. We will need to see what this means in practice. The motors will also supposedly go into deeper sleep state to reduce parasitic drag when coasting and when at standstill. Tesla has done something very similar in the past, and of course it's very nice to see that these manufacturers are still refining their products. You have to keep your expectations real, because the efficiency gains were not very noticeable in the real world. In fact, we will test this out, because all Taycans made up to this point are actually eligible for a software update, bringing them into sync with the 2023 cars. Our example is already booked into a dealer, and yes, you heard that right, it's not an over-the-air update, even though the Taycan supports over-the-air updates. Porsche's excuse is that depending on the age of the car, some of the packages are far too large to download. However, the car supports Wi-Fi, so you could easily connect them over your home network. But anyways, we think it's a bit of an excuse to update some electronic control units which are not ready to receive updates remotely, so the car needs to go into a shop, and perhaps finish off any outstanding recalls on the vehicles as well. Back to the video now. It's also funny how Audi was bragging about the e-tron motors, which do not use any rare earth metals in them because they are induction based, but the VW group seems to have forgotten that, because they now include lovely neodymium magnets in these motors. But anyways, to conclude the point, yes, permanent magnet motors are efficient and can be efficient in an all-wheel drive setup, but to say that they make the Taycan efficient is really pushing the definition, and personally I would have preferred a more traditional setup with a permanent magnet and induction motor, so each can play to their strengths. Anyways, moving on to the 800-volt architecture. More precisely, that is needed for achieving high charging power without hurting the battery. What you have to understand that despite the current coming into the battery being lower and achieving the same charging rate, the battery health depends on many factors, like the method of cooling the battery, the cell type and chemistry. Which brings me on to the point that even if you took the Taycan's battery pack and arranged the cells differently in terms of parallel and series groups, you could get to a different system voltage of, for example, 400 volts and vice versa. So it's the current or the load of every cell which would matter. Luckily, there is a way to describe this, and that's using the so-called C rating. It involves a pretty simple formula where you simply divide the instantaneous current by the rated energy of the pack, and you get the value itself. The higher the value, the more you are stressing the battery, so let's look at some examples. The Taycan with the bigger Performance Battery Plus, which has an almost 94 kWh gross capacity and 84 kWh net usable capacity, we need to do the math, divide by the nominal voltage of about 800 volts, and you get the energy rated capacity at about 115 amp hours. If you have no idea what I just did, I would recommend watching a video linked above, which we have done on covering the basics of understanding all of these units and the EV language. But anyways, back to the topic, the charging peak is just under 270 kilowatts at just above 20% state of charge, when the car is at about 770 volts and pulling 340 amps. So, using the formula we discussed before, we get a C rating of 2.9C. 3C seems to be the value which most manufacturers are aiming for, especially at the bottom end of the battery. Let's compare that to a Tesla Model 3 long range with a Panasonic battery, 82 kWh gross, 75 net, roughly speaking, and a nominal voltage of about 400 volts, giving us about 205 amps of energy capacity. The 250 kilowatt peak happens at about 20%, which is 380 volts in the pack, requiring 655 amps. So even though we have got a significantly higher number of amps, in other words, current flowing into the battery, it still only translates to a C rating of about 3.2, so tiny bit higher than the Taycan, but really not that big of a difference. What is impressive is that Porsche manages to maintain most of the charging power deep into the battery pack, but it also means that further down the line, the C rating of the Porsche actually exceeds the Tesla, and that begs the question, is that really healthy for the battery? Because with so many variables in battery design, there isn't a single rule of thumb to go by. If you're concerned, Porsche has an answer for it which is hidden in one of the battery charging menus, and that's a dedicated mode for reducing the load on the battery during high power rapid charging sessions. This limits the peak to 200 kilowatts, but it doesn't only chop that off the charging curve, it reconfigures the entire charging curve, which translates to a lower C rating at the higher state of charge portion of the battery pack, which would be the area of concern. Don't get me wrong, 800 volt is a very elegant system, and I hope we will see it on more vehicles in the future, because even if the charging situation is the same as with 400 volt, at least with the battery capacities we have these days in personal cars, high voltage, just like we know from very high voltage power lines which transmit power over long distances, reduces the amount of current in all the wiring for the same amount of power, which in turn reduces heat, or in other words, losses. So you can have an electrically more efficient system overall, and thanks to enabling the use of thinner wiring, also mechanically more efficient because you have got less mass to carry around. In the meantime, it has a bit of a drawback, because even though the Taycan is compatible with charging stations which are less than 800 volts, so I'm talking about the standard 500 volt 50 kilowatt chargers, it's constrained by the CCS1 standards on these older units, which even though theoretically could deliver up to 200 amps, realistically they were usually implemented at 125 amps. The way the voltage converter works in the Taycan is that it simply multiplies the voltage by 2. So at the bottom end of the battery pack, where the voltage is about 750 volts, the system has to match half of that at the station end, so it's asking for 375 volts and obviously for maximum current. So 375 multiplied by 125 volts, you get about 46 kilowatts, and that's under ideal circumstances, and as with any conversion you will have more heat loss along the way, so realistically expect about 45 kilowatts at the bottom end. In a couple of years' time, hopefully having to rely on 50 kilowatt chargers to do long trips will hopefully be a thing of the past, and you will not have to worry about it. It's just something to keep in mind in the meantime. To be fair, with the set of choices Porsche has made about the drivetrain, they have kind of engineered themselves into a corner. The combination of 800-volt architecture, which efficient on paper, but lowering the ceiling in terms of how much current it can provide, then selecting permanent magnet motors, which also have to be 800 volt to match the battery pack, having a slower possible acceleration rate, combined with the fact that, generally speaking, more current means more torque for any motor design. It also required a gearbox with a gear essentially below first gear for enabling faster launches, which, despite using permanent magnet motors, makes the car not as efficient as it could have been otherwise. Next up is, I would say, general weather robustness. Tesla quite often gets mocked for designing cars for perfect Californian weather and nothing else. And the German automakers, on the other hand, have a reputation of testing their cars thoroughly in winter conditions, in very hot conditions, to make sure that at least mechanically they will be as robust as possible. Regarding winter driving and EV efficiency, the car does come with a heat pump as standard, as well as heat scavenging from the drivetrain electronics, which really should help keep the efficiency as good as possible in cold weather conditions. The whole HVAC and thermal management system has two heat exchangers. A standard radiator to remove heat from the drivetrain just in front of the left wheel arch, and an AC condenser just here in front of the right front wheel arch. I would genuinely like to know which engineer came up with this design and the placement, and putting the cooling fan pretty much right in front of the wheel, because whereas it could be acceptable on a car like the Taycan sedan, it's downright crazy on a vehicle which you're supposed to take off-road, because out of the Taycans we sold in the past, we had a customer complain about a weird noise coming from the front, and it was in fact a stone stuck in one of the cooling fans, most likely just from driving down a gravel driveway. Plus, on top of that, it's definitely not a one-off occurrence. If you look at the Porsche forums, they're full of the same issues where the cooling fan starts catching against stones accumulated in the exhaust. In the better case, it gets rectified early and it just involves clearing out the debris. In the worst case scenario, the fans can overheat and fail. And as you can imagine, replacement parts and labor from Porsche can get quite expensive. And last, the ergonomics, because this is again something you would expect from a Porsche or a traditional manufacturer to really get right. Well, the seating position is great, comfort excellent, the entire cockpit looks fantastic, but there are a few odd things which just do not make sense. Like the fact that the interior trim, which sticks out from underneath the dashboard, sticks out quite considerably, about an inch, from the flat portion of the dashboard. So every single time, if you're not careful and you're jumping into the car, it's in the perfect height to hit your knee. The cup holder just underneath the secondary screen for air conditioning is placed in such a way that if you put your phone in it, or God forbid a large water bottle, it totally obstructs some of the controls, like for example volume and the on-off button. If you want to get into the cubby space underneath the middle armrest, you can only unlatch it from the driver's side. It protrudes out quite a bit, so it's difficult to get into it and doesn't stay upright, so it flops back down. This is probably done for safety, but the B-pillar sits quite far forward. So if you're getting in and out of the car frequently, this bit of hard plastic starts showing sign of wear very quickly. The AC air vents are completely software controlled, which I personally don't have an issue with, if there is a reason to make them software controlled, like in the Model 3, where there are two intersecting planes of air. Video with more details on that linked above, but in the case of the Taycan, they are literally traditional air vents. Arthur doesn't really get on with the customizability of the instrument cluster, because unlike previous Porsches, where you can use the left scroll wheel to customize the left dial and the right scroll wheel for the right dial, here you have to only use the right side and swap through the different options using a dedicated button. And then if you press the scroll wheel in before scrolling, it does something different than just scrolling the scroll wheel. It's one of those things which you will definitely get the hang of once you live with the car, but we have seen it firsthand that trying to explain this during handovers can be quite complicated. And there are many more of these, let's just say, UI design gaps in the software as well. I realize I've been quite harsh on the Taycan towards the end, and to be fair, we absolutely love the car, so it's only fair to bring out some positives as well. The active aerodynamic elements are definitely top-notch. First, in the front, you have got active shutters, which open and close depending on which mode you are in and the cooling requirements. Because if you look closely, not only do they house the heat exchangers for cooling down the drivetrain, but there's also a dedicated air duct channeling fresh air right over the brakes in the front wheel arches to help cool them down as well. Then we've got the front slits creating an air curtain over the rotating front wheels to reduce drag. Similarly, on cars not equipped with the motorized charge port, there's an opening to channel air further down the side. Unfortunately, it's blanked off on this version because it probably houses some of the actuators for the charge port. And in case of the sedan, an active rear spoiler. On the topic of brakes, a very interesting is the Porsche surface coated brake, which features tungsten carbide coated brake discs, which really makes sense in an EV because even if you drive mostly using regen, they should prevent the formation of surface corrosion. As standard, you do get air suspension and adaptive dampers, but you can go further with active anti-roll bars, rear wheel steering, and full-on torque vectoring. To keep the interior space usable in the back, there are cutouts in the battery pack to create footwells just like in a combustion engine vehicle, meaning you're not sitting in an awkward position very low down to the floor, which can be the case with some of these lower roofed EVs. And as a last example, I can list the very impressive instrument cluster, which features a massive curved screen, which can be configured to show different dials or a full screen map. And the edges have touch capacitive buttons on them, which are very easy to click actually, because you can rest your hand on the binnacle itself. And I think that's about it. I hope you enjoyed the video and learned something new. If you appreciate the honesty, because at the end of the day, we will be selling this car at some point, hit the like button, and as always, thank you very much for watching and see you in the next one.